So next we're going to be talking about function operations, where we will be adding, subtracting, multiplying, dividing, and composing functions together. So we are going to be working in function notation. So remember that the letter in front tells us the name of the function, and then what's on the inside tells us the variable that we are working with. Okay. Now when we are looking at this function notation, if we have two functions added together, this format means the same thing as this one. So if I see it like this, it's still telling me to add the two functions together. Same thing with subtraction. So I can have it in between our two functions, or I can say f minus g of x. Okay. Multiplication is the same. So I can take f of x times g of x, or it means the same thing to say f times g of x. Division. When we are dividing our two functions together, remember that we can't have 0 in that denominator, so we would have to state the restriction for that. So again, our denominator can't ever be equal to 0. So if there's something that we can substitute in for our variable to make that happen, then we need to make sure to list that as part of our answer. Okay. And again, I can have f of x divided by g of x, or we would say it as f divided by g of x. Okay. Now these first four should be review from our previous units. So the new one is going to be this composition. So the operation to tell us to do the composition is this open circle in the middle. So it's important that we're paying attention to whether we have a closed circle or a star like this for multiplication. Whereas if we have the open circle, that's telling us to do that composition. And a composition is another way of saying to evaluate. And we're talking about evaluating a function within a function. Okay, so the way that we say this is f of g of x. Okay, so that's the way that we would read it. Same thing, this one, this is f of g of x. Or if we write it as if we were evaluating it, so like this is f of g of x. Now we can also see it the other way. So I can see this as g of f of x. So when I look at this, this is telling me to take whatever that f of x function is and evaluate it into the g of x function. So this means the same thing as g of f of x. Okay. So if it's easier for you to think of it like this, or again like this, that's how I would think of it. So we're just going to do a bunch of practice. So remember, when we are doing our function operations and we are talking about those restrictions, we have to state the restrictions of both the original functions, if there are any, and whatever our answer is simplified to. So as I'm looking at my f of x, my g of x, and my h of x, with the way they're written right now, because I have a linear and then two quadratics, those don't have any restrictions that I need to worry about. So unless I have a fraction or a square root that comes into play somehow, all of my restrictions should be none for these answers. Okay. And then we're just going to replace the name of the function with its expression and then simplify. So on 13, this is asking us to subtract. So I'm going to take my f of x function, so that is 3x plus 1. And I'm going to put it into parentheses since I'm substituting right now. And then we are going to subtract our g of x function. So that's this x squared minus 2. Okay. And now we're just simplifying. So if you need to, we can distribute a positive 1 to both of those and then a negative 1 to both. So this would become 3x plus 1 and then minus x squared plus 2. And then we would combine like terms and write it in standard form. So I will have negative x squared plus 3x plus 3, and my restriction would be none. Okay. Now, if you can do that in your head, that's fine. So if you can see that this is going to be a negative x squared and we have to write that first, then I can just put that first. And then 3x doesn't have anything to combine with, so that's just that positive 3x. And then 1 minus a negative 2 means that we're adding. So 1 plus 2 gives me 3. So if you can do that part in your head, you do not need to show this step right here. So we do need to show our substitution step. But from our substitution step, you can go to your answer if you are able to do that in your head. Okay. All right, so I would like you to pause the video and then go ahead and work on 14 and 15 and 16 to see if we can substitute and simplify correctly. So 14, we are adding our g of x, so x squared minus 2 plus our h of x, so x squared plus 7x plus 12. So I'm just going to combine my like terms together. So 2x squared plus 7x plus 10. And I have a quadratic equation, so that means that my restriction is none. So next one, we are multiplying. So 3x plus 1 times our g of x, so x squared minus 2. So I'm going to have to FOIL. So this will be 3x cubed minus 6x plus x squared minus 2. And then I do need to write it in standard form, so I have to write it from highest power to lowest power. So 3x squared plus x squared minus 6x minus 2. And again, my restriction is going to be none. Oh, let me fix my power. That should be a 3. There we go. Okay. All right, so 16, g of x, we have x squared minus 2 over h of x. So that is x squared plus 7x plus 12. And then since I can't divide the same thing out of every single term, I can't simplify that fraction anymore. So now I just have to check to see if I have anything that can be substituted in for x in the denominator to make this a 0. So that means I have to try and factor this. So my a is 1, so I need two things that multiply to be 12 and add to be 7. So I would need to choose 4 and 3. So then that means that my restrictions would have to be x can't equal -4 and -3. So again, I'm taking whatever's in those parentheses, setting them equal to 0, and then solving to get this part of my answer. All right, so as we continue, we are now transitioning into the composition part. And I know that because I have this open circle here, or I'm looking at this as an evaluative problem. So what I like to do for our compositions is rewrite it so that way we are thinking of this as f of g of x. So the second letter is always the one that goes inside of that first letter. So really what this means is I'm doing f of g, and my g is at x squared minus 2. So then this is telling me that I need to plug that x squared minus 2 and for all of the x's into my f of x equation. So I'm replacing this x with that x squared minus 2. So this will be 3 x squared minus 2 and then plus 1. And now we're just simplifying. So I would need to distribute. So 3x squared minus 6 plus 1. And then if I combine like terms, this will be 3x squared minus 5. And I'm not going to have any restrictions since I have that quadratic equation. All right, so why don't you guys go ahead and pause the video and see if you can figure out 18 and 19. All right, so this really means f of our h function. So that is the x squared plus 7x plus 12. So I'm substituting this whole thing in for all of the x's in my f function. So 3 times x squared plus 7x plus 12 plus 1. So if I start to simplify, I would distribute. So 3x squared plus 21x plus 36 plus 1. And then if I combine those like terms, I will have 3x squared plus 21x plus 37. and my restriction would be none. And again, I know that because I have that quadratic equation and I don't skip any x values in that. All right, on 19, we are doing g of f of x. So my f of x is that 3x plus 1. And then now I'm substituting that 3x plus 1 and for all of the x's in my g equation. So I'm replacing this with that 3x plus 1 and then simplifying. So that is going to be 3x plus 1 quantity squared minus 2. Okay. Now this is where it's important to remember our shortcut rules for our powers. So I'm not allowed to distribute my 2 in and say that this is 9x squared plus 1. And that's because I have that plus here. So remember, when we square something, that really means that I have to take it times itself. So I need to write this out twice. And now that we have it written out like this, this tells me that I have to FOIL. So I'm going to take 3x times 3x, so 9x squared. 3x times 1 is 3x. 1 times 3x is another 3x. And 1 times 1 is 1. And then I have that minus 2 on the end. So now I'm just combining my like terms. So 9x squared plus 6x minus 1. Quadratic formula means I don't have any restrictions to worry about. All right, that last one. So here we have that number where our x normally is. So it's still a type of evaluating problem. So this is telling me that I'm going to start by plugging 3 into all of the x's in my g function. So we're going to start by figuring out g of 3. So again, as I go back to the top and look, here's my g. So I'm plugging 3 into this spot, and then we're going to simplify right away. So this will be a parenthesis 3 squared minus 2. So this is 9 minus 2, which is 7. So now that I know this g of 3 equals 7, that means I'm allowed to replace it in this format. So if I'm replacing this with what it's equal to, then next we are doing h of 7. So again, that tells me that in my h equation, so in this one, I'm going to replace all of my x's with that 7 and then simplify. So this will give me 7 squared plus 7 times 7 plus 12. So this will be 49 plus 49 plus 12. And then 49 plus 49 plus 12 is going to be 110. So this would be my final answer. And then because I have a single number, I don't need to worry about the restriction. If we did want to write it, then we would just put none. All right, so we're going to continue with some more practice. Okay. So as we look at these problems, this time in one of my original equations, I'm dealing with a square root. So I do have a restriction for my g function. So I'm going to write that down. So I'm going to have all the x's that are greater than or equal to -3. Okay. So that also tells me anytime I use my g of x function in these function operations, I have to include that restriction. Okay. And if we have other restrictions we need to worry about, then we would also include those as well. Okay, so let's go ahead and pause the video, and I would like you to work through all of these. And then I will go through them so you can compare your work and your answers. Now, anytime we have a number, we also don't need to worry about the restriction. Now on 14, there's a couple different ways that you can work through this correctly. So to start with, I can just ignore the fact that I have a number here and treat it like an x. So I have my h and then minus g. Okay. So notice how I can't combine any of like terms because of my square root symbol here. So at this point, I'm going to substitute in that 6 for all of the x's. And then we will continue to simplify. So 6 plus 2 gives me 8. And then 6 plus 3 is 9. The square root of 9 is 3. And I'm not putting the plus minus sign here because this was originally written in our problem. We didn't write it in to solve. Okay, so we're only going to take the positive answer when we're simplifying. So 8 minus 3 is going to be 5. Okay, and that 5 is within my restriction when I used g, because 5 is bigger than negative 3. So this is an acceptable answer. All right, so next, this really means h of f of x. And then f of x is our x squared plus 5. So that means I'm taking x squared plus 5, substituting it in for all of the x's in my h function. So again, I'm replacing this x with that x squared plus 5, and then we'll need to simplify. Notice how anytime I substitute, I'm putting parentheses around it. That's so that I don't accidentally lose a sign or forget that I have an exponent or forget to distribute something if I would have something out in front. So anytime you substitute into a letter, it's always a good idea to put that into parentheses so you don't accidentally make an easy algebraic mistake. Okay. Now with this, my only like terms are the 5 and 2. So this will become x squared plus 7. And then I didn't have any restrictions on my f of x or my h of x. And I ended up with a quadratic for my answer. So that means I'm not going to have any restrictions to worry about. Okay. All right, 16. This is telling me to do g of h, which is that x plus 2. So in my g function, I am replacing my x with that x plus 2. And then we are going to simplify. So this will really be the square root of x plus 5. Now, as I look at this, for my simplified answer, I have that x plus 5. So I can't take a square root of a negative number. So that means for this one, we would have to have everything greater than or equal to negative 5. But I also need to account for my original restriction. So you have to think of it as an and statement if we are going back to our inequalities. Okay. So if you need the visual, so I have negative 5 and I have negative 3. And if it's an and statement, we can only include the part where it's going to start to overlap. So we would only include this piece right here. So again, if we need to kind of see a visual of that. So everything bigger than negative 5, everything bigger than negative 3. So here's where that overlap is happening. So that means for my restriction then, when I state it for my final answer, it has to be x greater than or equal to negative 3. So this is where we need to be careful that we are including the restriction from both our simplified answer and if we had a restriction on the original problem. Now, if we had no idea that this was part of our simplification, then we would just have this as our restriction. But because I know where this came from, I have to include that as part of my restriction as well. Okay. All right, next one. So back to a composition. And again, I know it's a composition because of that open circle. So this means f of h of 7. So to start with, we're going to focus on this h of 7. So this tells me I'm going to put 7 into all of the x's in my h function. So I'm going to put it into this. So h of 7 equals 7 plus 2, which is 9. And now that I know that h of 7 is the same thing as 9, I'm going to plug the 9 into my f function. So we're doing f of 9. So now replacing all of the x's in f, so that x squared here, with 9, and then simplifying. So we're doing 9 squared plus 5. So this is 81 plus 5, which is 86 for my final answer. And again, I have that number, and I don't need to worry about any restrictions. All right, last one, so 18. So we're doing f of x. So this tells me that I am plugging f into itself. So I would just do f and then that equation, so x squared plus 5. And then I'm replacing that x squared in this with that x squared plus 5. And simplifying as much as possible. So again, because we are squaring that group, I'm going to write this out twice, which tells me then that we will need to FOIL. So as we FOIL, this will become x to the 4th plus 5x squared plus another 5x squared plus 25 plus 5. And then we are combining our like terms. So x to the 4th plus 10x squared plus 30. And I'm not going to have any restrictions. All right, in the last part of our video lessons for this section, we are going to talk about the story problems and how to work through those.